Hello guys, welcome back to my channel, Mason African Motives. Still working on the question paper which is on heat for engineering science N3. So we shall actually focus on heat there. We have this part and also the second part there, which is to make a total of 15 marks. So that's what we had from this question paper. So we shall quickly rush through the question and see how we are supposed to answer these questions. So the first part on 5.1 is to explain the law of conservation of energy. So what is the law of conservation of energy? So we know that guys, we cannot create or destroy energy, but energy actually can be changed from one form to another. So that is the law of the conservation of energy, that energy cannot be created or destroyed but can be changed from one form to another. Thus, heat gained is equal to the heat lost by an object. And I think we have been talking about this in many questions, which is also the application of the question that they want us to do on this part here, on this question, which had 4 marks there, where we are given that 45 steel shafts are cooled down in 5 liters of oil. The initial temperature of shafts is 118 degrees Celsius and that of oil is 20 degrees Celsius. Each shaft has a mass of 750 grams. Take note, each shaft, but we have got 45 steel shafts in this case. All right, so we've got 2 things that we are going to focus on here, which is the oil and the steel shaft. So we've got the steel shafts in this case. So for the oil there, okay, let's talk about the number. We've got 45 and they've given the mass, which is 750 grams, but to kgs, remember you divide by 1000 because in a kg we have got 1000 grams. So this is going to give us 0.75 kgs. That 0 is not important, so which means the mass of the steel shaft in this case is 0.75 kgs. Just list down for information. So we are given what else are we given? In 5 liters of oil, take note guys, we are given the number of liters of oil. And what is the relationship between the number of liters and the mass in kgs? So each liter is equivalent to 1 kg. So if we have got 5 liters, that means 5 is going to give us 5 kgs there, because 1 is to 1, so 5 must also be 5. So we've got mass of oil here, let's just put all like that, which is 5 kgs. All right, what else do we have? The initial temperature of the shafts, which is the steel shaft, is 180. So this is the temperature for the steel shaft, which is 108 degrees Celsius, and that of oil is 20 degrees Celsius. So this is the temperature of oil, which is 20 degrees Celsius. And okay, the mass, we talked about this one. Calculate the final temperature of the mixture, which means the mixture is a combination of the steel and the oil. So that is your T2, which is going to affect both conditions. So we need to calculate the value of T2. All right, what areas are we given? Use the specific heat capacity of steel, which is the specific heat capacity of steel as 500 joules per kg degrees Celsius. So we are given the specific heat capacity for steel, which is 500 joules per kg degrees Celsius. That is what we had in this question. And that of oil, take note, it's 1.5 kilojoules, like that. So you have to convert this 1.5 kilojoules per kg degrees Celsius. So kilo means 1000, so it's 1.5 times 1000, which is going to give us 1500. So this is going to give us 1500. That is the specific heat capacity of oil is 1500 joules per kg degrees Celsius. This is supposed to be in joules. Okay, so what is going to be T2. So as you can see, we have listed down the information. Now we know that, remember that the heat lost, even from the definition that we had from the conservation of energy, that the heat lost is equal to the heat gained. So that's Q lost, which is heat lost, is equal to Q gained. So which one lost the heat and which one gained? It is the steel which lost this one and this one gained, because remember, you are cooling this in oil, so this one is going to gain and this one is going to lose its heat. So remember, for this one is going to be mass of steel, so this is the steel which lost and the oil is the one that gained. So it's mass of steel times the specific heat capacity of steel, then T steel minus temperature 2, which is the final temperature of the mixture, which is equal to mass of oil, this time the specific heat capacity of oil, then this time it's T2 because this one is the one that gained. So you subtract its temperature from the final temperature. Here you subtract the final because it's losing, so you're going to subtract the final temperature. That is the case there. So you can substitute so that you can calculate this. So let's substitute this mass of steel, 0.75. So as long the information is there, you just substitute here. Then the specific heat capacity of steel, that is 500 joules, into TS, which is the temperature for steel, 180, minus T2, the one that we want to obtain. So it's 180 minus T2, which is mass of oil. Remember, from those liters we obtain the mass, times the specific heat capacity of oil, which we are given as 1500, into T2, the one that we want to obtain, minus the temperature of oil, which is the initial temperature of oil at 20 degrees Celsius. So you formulated an equation. So let's apply our mathematical skills here to solve. Let's just combine these two. You combine also these two there. So in this case, from what we are having, this is gonna be 40. We multiply these guys. All right, this is 45 there, guys. We didn't involve this here. I'm seeing this part. This is mass of 1. This is 1 and we've got 45. So let's multiply by 45 here to obtain the total mass, because there are 45. I hope someone saw that. So this is supposed to be times 45 exactly. Now we have included the 45 steel bars that we have, so you have to multiply exactly. So that's gonna give us something like 16875 into 180 minus T2, like this, which is equal to, multiply these two, that's gonna give us 7500 into T2 minus 20, like this. All right, so someone can expand brackets, multiply these two, that's 3037500, like that. This one times this one, that's minus 16875 T2, which is equal to 7500 times T2, that's 7500 T2, minus 7500 times minus 20, which is going to give us 150,000, like that. So you can transpose, collect like terms and so forth. So you can just collect this to the left hand side. Is going to add, because it was a minus, so it's going to add to this one. So if you add these two, you are going to obtain 3187500, like this, which is equal to, transpose this to this side, is going to add. It was a minus, take note, so it's going to add with T2. So it's this value plus this value. So it's going to be 24375 T2, like this. All right, so remember, you want to find T2, so definitely you have to divide by 24375 by 24375. So this can cancel, you remain with T2. So your T2 is going to be if you divide these two values together, you must obtain something like 130,769,2308, something like that. So this is going to give us 130, you can round off to 1 decimal place because it's temperature, so it's going to be 8 degrees Celsius, like that. So that is our T2, or you can just round off to 3 decimal place, depend with what you want. But normally temperature, I prefer to use that to 1 decimal place, just like the way you round off money or something else. You have to be like specific. So that's what we. So as you can see, guys, there's a lot of calculations there, which is actually, I don't know if it is worth 4 marks, but that's what they do. They give you 4 marks or 5 marks, but that's what they give you. So an overhead crane is used to carry mold in a foundry workshop. All right. The beam overhead crane has a length of 19 meters at a temperature of 18 degrees Celsius. After molding process, the temperature of the beam of the overhead crane is expected to rise to 100 degrees Celsius in the foundry. Use the coefficient of linear expansion of the beam, which is to calculate these. All right, so let's see. This is an overhead crane. We are given the length, which is initially, there is a certain length that is there that you are given initially. So let's just take this as our original length of 19 meters at this temperature. So it's 19 meters at temperature 1, which is the initial temperature of 18 degrees Celsius. Then it increased, it's expected to increase to 100 degrees Celsius. So that's going to be your T2, and you're also given the coefficient of linear expansion, which is the coefficient of linear, which is your alpha, as 25 times 10 to the exponent of -6 per degrees Celsius. So the question is, calculate the following: the increase in temperature of the beam, just the increase, guys. All right, so 5.31, that is the increase, and we know that the increase in temperature, that is the change in temperature, which is T2 minus T1, the temperature difference, that is the increase. So T2, that's 100 degrees Celsius, minus T1, which is 18 degrees Celsius. So if we are to subtract these two, that's gonna give us 82 degrees Celsius, which is the change in temperature, or the increase in what? In temperature, because remember it started at 18 up to 100, so that's an increase. All right, so the increase is the change in temperature. Okay, so what about 5.32? The expected expansion of the beam, the expected expansion of the beam in millimeters. So there are two options that we have, either to first convert this to millimeters or to convert your final answer. So you can convert the original length to millimeters. It was 19 meters, so to millimeters you multiply by 1,000, because remember 1 meter is equal to 1,000 millimeters. Is it 1,000 or 100? This is 1,000. Okay, so it's going to give us 19,000 millimeters. All right, so now the question is, what is going to be the expected expansion? Not just the expansion, which is expansion, that is the change in length. So remember, the change in length is equal to the original length times the linear coefficient of expansion times the change in temperature. So that's the original length, which is now in millimeters, of 19,000 in millimeters, times our alpha, which is the linear coefficient of expansion of 25 times 10 to the exponent of -6, like this, times the change in temperature, which is the increase in temperature that we determined here, which was 82. So we are going to multiply by 82, like that. So that's what you're going to have. So if you multiply these we are going to obtain something like 39.95, but already this is in millimeters, so that will be in millimeters. So that is the change in length of 39.9 millimeters. So that's what we had in this case. Okay, then the other question was the expected final length of the beam in meters this time. Take note about the instruction, guys, in meters. Okay, let's start by having the expected final length. What's the formula? So we know that this is the final length. So it's the original length plus the change in length, which is the increase in length. So the original length, we remember we had this original length in meters, so we can just write it in meters as it was, plus the change in length. So now on the change in length, we are supposed to work something, because this change in length, we obtained it, but it was in millimeters. This one is 39.95 in millimeters, but we can't add millimeters to meters because this is in meters. So we have to convert this to meters. How do we convert? Remember we said in a meter, did we write this here? Oh, let me just write in a meter. We have got 1000 millimeters. So to go back to meters, we have to divide this by 1000 millimeters so that it will be in meters. So dividing this by 1000, we are going to obtain 0.03995. That was 38, not 39. Where am I obtaining this 39? This was 38, guys. Yeah, I hope someone saw this. This is 38 there. I don't know what's happening there, but that was 38. So that's gonna give us 8 here, 3895, like that. So that's what you're going to obtain after dividing. 1, 2, 3. Yeah, it makes sense. It makes sense. That's 3 there. So this is now in meters. So these two can add each other in meters, which is going to give us 19.03895 in meters. So this will be our final length. So the final length, which is the final expected length, was going to be 19.03895 in millimeters. So that's how they can ask these questions actually. All right, let's see the last question that we had, which is on 5.45, which is we are given the temperature. The fig 7 above shows the water to steam process. So this is a water to steam process. Complete the process in fig 7 by filling the missing descriptions and symbols. So it's description and symbols. These are two things, the description and the symbol. Okay, write only the description and the symbol next to the question number. Okay, like that. All right, so what do we have here, guys, on 5.41? What's that? What do we have here? What do we have here? So remember, from the steam process, here we are still on water, so this is going to be the liquid enthalpy, which is HF. So HF, that's the liquid enthalpy. That is enthalpy there. All right, that's our HF here. So we move on to here. We've got water and steam, which is now evaporation. So this is HFG for evaporation, and we have got HG for the dry steam. So let's just write it down. Maybe someone wants to write this down, so let me just write it. So this is for evaporation. Okay, that is the liquid in enthalpy of evaporation. Oh, that's enthalpy there of evaporation. That's evaporation there. All right, then what else do we have here? We've got 5.43, which is for the dry steam, this one. So it's HG, that one, that's the enthalpy of dry steam. All right, then after that, this steam is going to give us superheated steam now here. So this is superheated steam, H soup, like this. So it's just enthalpy, just the enthalpy there, there's a Y there, enthalpy of superheated steam. So this is superheated steam, like that. All right, so this is what we had. Then we will be having your HSS, which is a continuation like that. So but for this one, that's what we had, and we've got 4 marks to make it a complete of 15 marks. So that's what we had, guys, on this question, to make it a total of 15 marks. So we shall come back again, guys, working on engineering science N3 question papers and revision. So if there are question papers or some areas that we need to work on, let's know on the comment section. You can list down those areas so that we can look into them before we write the exams, which are ahead of time. So that's it, guys, from Mason African Motives. Till we meet again.